Good afternoon to all the respected dignitaries and the participants. Thank you for your cooperation for the participant and the dignitary being patient with us as our session did not happen at 12 o'clock because Dr. Lalit was not available due to some issues. He is now available with us as we know that Dr. Lalit is an eminent scientist and researcher in the field of nuclear energy. He is here with us. He is an eminent officer and an eminent scientist of BARC, and his topic is research scope of nuclear energy in the field of nuclear energy. Dr. Lalit is with us. Welcome, sir, with us, and he will give you a talk on the research scope of nuclear energy. So I hand over the baton to Dr. Lalit, sir. Please, sir, thank you very much for your esteemed presence in this FDP talk. We are privileged to have you, sir. I am transferring the host rights to you, sir, so that you can share your talk and presentation with the participants. And once again, very warm welcome to you on behalf of the Lucknow University FDP and all the participants.
Thank you very much for introducing me, and thank you for providing me this opportunity to share some of the experience. So to start with, let me share my slides. Yeah.
Sir, I made you the host, sir.
Yeah. Thank you. So are my slides visible?
Yes, sir, it is visible, sir. It is
and please tell me, it is changing also?
Yes, sir, it is changing. It is continuously, sir, changing.
Okay. Thank you. Yeah.
Thank you, sir, for your.
So I'll be talking on research scope in nuclear energy. And we know nuclear energy is continuously, the business of nuclear energy is growing in throughout the world. And many countries, they are playing a leading role, like Russia, China, and they are several reactors are under construction currently. Even and India is a very dynamic program in the nuclear energy. So we see, like, because it is a multidisciplinary domain, and generally it involves the knowledge of all the basic sciences as well as engineering sciences. So we will discuss like whatever the knowledge that are required, or what all the research scope in those particular domains in the nuclear energy, that is so that the people can take it forward and think in that particular direction. So let me first discuss the nuclear reactor. What do you mean by the nuclear reactor? So nuclear reactor, it basically in this the fission reaction takes place, and we all know like what is a fission reaction. When heavy nuclei, there is a heavy nuclei which can split, and after splitting it release some of the radioactive components, and some neutrons, 2 to 3 neutrons in one reaction. It releases and also 220 million electron volt of energy is released in one reaction. And now these 2 to 3 neutrons, individual or every neutron is responsible to create one more chain reaction. So what happens? One neutron reacts with the uranium nucleus, and again after that it will release the 2 radioactive components and 220 million electron volt of energy, plus again it will produce 2 to 3 neutrons. And so you can see in every fission reaction, almost 2 to 3 new neutrons are getting generated, as well as 220 million electron volt of heat energy is released in every reaction. And you can see, so it means the neutrons are the main source of energy, because when it strikes to the uranium nucleus, the fission reaction takes place. And hence, in this fission reaction, the neutron population keeps on increasing, because in every reaction, almost 2 to 3 neutrons gets generated. And every neutron again will be responsible to create one fission reaction. So the neutron population keeps on increasing exponentially. There is an exponential growth in the neutron population, as well as there is exponential growth on the thermal energy that is being released, because in every reaction it is releasing 220 million electron volt of energy. And hence, it is necessary to control this population of the neutron, because if you will not be able to control the population of the neutron, it will keep on producing, the huge amount of energy in every reaction, and it will be difficult for our mechanical components or instrumentation to accommodate this huge amount of energy, for which these components are not designed even. So ultimately, the nuclear reactor, it is a device to design, which is designed to maintain this chain reaction. And how it is maintaining? By producing the steady flow of the neutrons. So it means whenever there is an excessive flow of neutron, its roles and responsibilities to control that neutrons, either by through some mechanism. We will definitely see when we will be looking at the working mechanism of the nuclear reactor. This device is designed to maintain this chain reaction, producing the steady flow of neutrons that is being generated by the fission of heavy nuclei. Or we can say it is an apparatus in which heat produced during nuclear fission reaction for the generation. So that heat is transformed into the electrical energy. So the thermal heat is transformed into the electrical energy. So this is what the nuclear reactor does, or the main function of the nuclear reactor. Now let us see the various components of the nuclear reactor. I will be only touching upon the main components, although it consists of thousands and lakhs of components. I will not be touching on them, but from the functional point of view, as I said, the device is used to sustain the chain reaction. So for that particular activity, what are the various components that are required for to achieve the overall functionality of the nuclear reactor? And then we will also see in this slide the working mechanism of the nuclear reactor. So if you are able to see this figure, there is in the left side, there is a one dome type structure, and we will talk about the dome type structure sometime later, but it is known as the confinement shell. And if you see the main components of this confinement shell are the reactor core and steam generator and pump. Let us talk about these components. So if you are able to see the rectangular shaped structure on the left side of this inside this confinement shell having the rounded corners. This structure is known as reactor core, where basically the fission reaction takes place. So it means the fuel is basically the nuclear fuel is there in the reactor core, and generally the uranium, plutonium, these are acting as a nuclear fuel, which is the heavy nuclei basically. And as I said, the fission reaction, the mechanism of the fission reactions takes place by spontaneous fission of this uranium nuclei, and after the fission, the two radioactive components gets generated along with 2 to 3 neutrons plus 220 million electron volt of energy, and these neutrons again will keep on striking the uranium nucleus, which is inside the reactor core. And hence, inside this reactor core, the population of the neutrons increase exponentially, as well as the thermal energy also increase exponentially. But because this reactor core is made up of steel, and we know like steel is also having a melting point, and so this much of huge energy we have to basically control. And how we can control? By controlling the population of the neutrons. So how we can control the population of the neutron is you are able to see there are the control rods. If you are able to see the striped structure inside the reactor core, having white and red color stripes. So the white colored stripes are the nuclear fuel. We will see the detailed structure of the nuclear fuel in the later slides. But these red striped structures in the reactor core are known as the control rods. And these red structured basically stripes are hanged from the metallic string, and you can see there are the metallic string vertically through which these control rods are hanged, and which are basically controlled by the mechanical clutch. You are able to see there is a mechanical clutch from which all these strings are hanged. And why? So basically this mechanical clutch can control the immersion of the control rods into this reactor core. So, and these control rods are basically made up of the cadmium, so that which has the property of eating all the neutrons. So depending on how much neutron population I need to control, I will immerse the control rod into the reactor core accordingly. So the percentage of the immersion of the control rods into the reactor core will depend on the number of neutrons that I want to control inside this nuclear reactor, inside this reactor core. And if you are able to see, this reactor core contains one inlet and one outlet. So what happens from the inlet, the cold water needs to pump into the reactor core, and there is a pump basically which can pump the cold water into the reactor core, and so basically that water is flowed inside a mechanical pipe, and when it touches when it passes through this reactor core, because where the nuclear reaction is taking place, and it is a lot of thermal energy is there inside this reactor core. So when this coolant or the cool water, which is also known as coolant, that passes through the reactor core, this temperature of the control rod gets exchanged to the cold water, and it becomes very hot. And that hot water comes out from the outlet of this reactor core. So generally, the outlet temperature of this hot water is almost 300 to 400 degrees centigrade. And if you go, if you proceed further, this pipe is connected to a steam generator, which is basically a rectangular kind structure having the dome shaped, and in which contains basically two logical compartments. In the lower logical compartments, it is filled with the water, and when it is where the cool water, normal water, basically we fill the normal water, and when this high temperature water coming out from the outlet of the reactor core is whose temperature is almost 300 to 400 degrees centigrade, touches the water inside the steam generator, it suddenly converts into the steam. As we know, the boiling point of the water is 100 degrees, and after that it can convert into the steam. So basically, the steam generator contains. Any doubt? I'm getting the voice. Please let me know. Or otherwise, I'll be requesting all the participants to mute themselves so that who wants to listen, at least they can listen. Yeah. So this logical compartments basically is filled with water, and when it converts it into the steam, it gets accumulated in the top portion of this steam generator because the steam density is lighter. And here you can see the top portion is the steam, which is basically which flows through the mechanical pipe and connected to the steam turbine to drive this turbine. Basically, there is a shaft, and this steam has the energy which gets converted into the mechanical energy. So, and that mechanical energy, it means the turning the shaft is a mechanical energy which is coupled with the electrical dynamo, and that is from which the electricity gets generated, and that can be reached to the consumers. Now, coming to the loop, we have to complete the two loops which are important to know. What happens, like, when the hot water from the outlet reactor core gets, it exchanges the heat with the cold water, which is in the steam generator. Then after exchanging the heat, it will again cool down, and that cool down, because it contains a lot of energy, we should not waste it, and that again will be pumped into the reactor core, and again it will exchange the heat of the reactor core, and again it can exchange the heat into the steam generator to create more and more steam, and the process continue throughout the lifetime of the nuclear reactor, which is almost 40 to 50 degree, 40 to 50 years. Okay. So ultimately in the confinement shell, there is the major components are the reactor core and the steam generator and the pump, which can pump in the cold water into the reactor core. And this is steam. Now, what after the turbine, after driving the turbine, what happens to the steam? So because all the steam will not be utilized, only like 30% or 28 to 30% only steam can be utilized to drive the steam turbine. So what happens like about the 70% of the steam? So that steam basically comes down and it collects into the condenser. So there's a condenser, and the role of the condenser is it basically condenses the steam, and so the non-saturated steam basically, because the saturated steam generally utilizes to drive the steam turbine, and the non-saturated steam basically comes down and it gets condensed, and we know all the condensation process. When the hot thing touches the cool surface, it gets converted into the water, and then the water again will be fetched or can be pumped in into the steam generator. So this is a secondary loop where the steam is getting is being utilized to drive the steam turbine, and the waste steam or the non-saturated steam again can be condensed uh, and pumped in into the steam generator, so that again it can be its heat energy can be utilized into the steam into the steam generation. And now there is a but what is the source of the cold water that is coming all the way to the condenser? So this cold water we have to take from the water bodies, and water bodies could be river, or could be lake, or could be ocean. So generally the nuclear power plants, if they are installed near the water bodies, then from there the cool water can be drawn, and where which can be used for the to condensate. This is steam which is coming all the way from steam generator to the condenser. Okay, and this tertiary loop will also keep on continuing, and then it exchanges some of the heat, and this water becomes warm, and that warm water have to be released into the same water bodies. But there are the mechanisms which basically controls the temperature of the outlet water which are being released into the river or lake or ocean, and so that the water bodies should be their life should not be compromised, right? So this is the entire mechanism, working mechanism of the nuclear reactor, where we can see the ultimately the fission reaction, how this nuclear energy can be converted into the heat energy, then heat energy is converted into the mechanical energy, and then mechanical energy is converted into the electrical energy. And the process keeps on continuing throughout the operational period of the reactor. Now, so this basically this confinement shell is known as the containment. So, and we will discuss more on this containment. What are the technological measures that needs to be taken for the design of this containment? That we will see later. Now, coming to let us try to go in the exploratory mode, and we will try to explore the components so that we can understand what could be the research scope on designing on those components. So if you see the pressure vessel or the tubes, which is nothing but this is a reactor core. It is also known as a pressure vessel. Why pressure vessel? Because it has to maintain in a very high pressure. Why pressure? Why high pressure? Because otherwise the liquid that is flowing inside as a coolant will suddenly convert into the steam inside. So if you are not able to maintain the sufficient pressure, it will convert into the steam, and it can have a very safety consequence. It can fail your fuel basically. We will see how it will do that. So ultimately, to overcome this issue, we have to maintain a substantial pressure inside this reactor core or inside this pressure vessel. So generally, this pressure vessel, if you see the second diagram, this is the pressure vessel picture. It is generally made up of robust steel, and it contains the reactor core and the moderator and the coolant. Or it may be a series of tubes basically. So either there is only one container where the entire fission reaction is taking place, or it may contain the series of tubes, and in the series of tubes you can fill in the fuel elements. So then fuel will be in the form of bundles basically, where you can fill in every tubes, and then that tube needs to be pressurized. So it may be a series of tubes holding the fuel and conveying the coolant through the surrounding moderator. We'll see what moderator is. Basically, moderator is to reduce the energy levels of the neutrons that are coming out. We'll be touching on those aspects. So now there are various research scope in this. First of all, uh, nowadays, the lifetime of this pressure vessel is only like 40 to 50 years. And in any nuclear reactor, the life of the nuclear reactor depends on the life of this pressure vessel, because it is only the one-time installation. If its life is over, you cannot replace it. It is not replaceable at all. The reason is because it is under the very highly radioactive zone. And like the half-life of radioactive components that ranges from seconds to billion of years. And hence, you cannot manually, it is not allowed to enter into this such radioactive zone for the replacement point of view. So, and a lot of research is going on how we can increase the life of this pressure vessel. Even the people are striving up to 100 years, so that it can reduce the brittleness, because after 50 years or 40 years it starts as brittling, and you should be able to design such that you can minimize the brittleness, or you have to innovate some kind of material which through which you can reduce the brittleness, or you can innovate some kind of process from which you can ensure like it will brittle after more longer period of time. So now the next interesting thing is reactor core. Here I have taken a detailed view of the reactor core, and let us see the structures, what basically it contains. So if you are able to see, uh, these were the stripes which I was showing in the first slide, and like the controlled the fuel rods. Here I am showing with the uh, vertical black color stripes, which are basically the uranium fuel rods, which are kept. It is a pressure tube like structure, and then there are the control rods. You can see the three control rods which have been lifted upside from the mechanical clutch, and these control rods are made up of cadmium because or boron, because it has a good property to eat the neutrons. And then there is a moderator. Now let us understand what moderator is. So what happens when in any nuclear fission reaction, when the radioactive components gets created and 2 to 3 neutrons gets generated, these neutrons are fast neutrons and having very high energy levels, almost in the form of EVs, several EVs, and because they are having very high energy levels, they will not be able to strike to the uranium nucleus, and hence we will be losing all the neutrons. We will not be able to sustain the chain reaction because every neutron is a fast neutron, is a fast enough that it is not able to strike the uranium nucleus. And hence, it is very important to make sure that your neutron will be able to strike the uranium. And for this, we need to thermalize the neutrons. It means we have to lower down the energy levels of these neutrons and to 0.025 electron volt. And because this energy will be good enough to hit into the uranium nucleus and to sustain the fission reaction. So the moderator job is to thermalize the neutrons. Thermalize means to lower down the energy levels of the neutrons. So what happens? There are the tubes which basically in which we can fill the moderator, and these tubes are put adjacent to the fuel rods because where the neutron reactions are taking place and from which the neutrons are getting emitted, and when they are emitting, it basically touches the moderator and which basically thermalizes this neutron energy. And after thermalizing, it is able to hit the uranium nucleus to convert or to sustain the chain reaction, to sustain the fission reaction. Then you can see so in this reactor core, you can see there is an inlet from where the coolant is going, and there was the outlet. It was the same like I have shown in this figure. So in the inlet, the cool water is flowing, and in the outlet, the hot water is coming out, which is basically going to the steam generator. And this entire boundary is known as the reactor. And if you see the outside this core, there is a pressure vessel. This is known as a pressure vessel, and which is coated with a reflector. Now let me make you understand the principle of the reflector. So what happens when the neutrons, although we are thermalizing the neutrons from the moderator, but still there are some neutrons which are not able to thermalize, probably because everything will not have 100% efficiency. So there could be 2 or 3 neutrons which are not able to thermalize, and that will try to come out from this boundary. And when they will try to come out, they will try to escape from the pressure vessel boundary. And you can see, like, because the neutron is the ultimate source of the nuclear fission reaction, and if we will start losing our neutrons, we will not be able to create the fission reaction or sustain the fission reaction. So what happens? There is a reflector whose role is to reflect back those neutrons which are trying to escape from the boundary of the pressure vessel. So here there is a coating of the reflector inside the pressure vessel, whose responsibility is to reflect back all the neutrons that were trying to coming out from this reactor core, basically. So there is a lot of research scope in basically designing the control rods because it also must have a long life. Earlier, we used to people were using boron but later on they saw like boron is it becomes brittle very fast, and it can break down, and then it will be difficult to take it out from the reactor core. And later on, more advanced research was carried out, and the cadmium was, invented, which can act as a, good control rods. So basically, there is a lot of uh, research scope in designing the control rods. What should be the material that can be taken up, and how the design should be there, so that we can maximize the efficiency of the nuclear reactor, because any reactor is not having the efficiency more than 35%, 35 to 40%, and reactor is having the efficiency almost of 28%. Okay, and definitely the coolant, because the coolant is acting to as a it is a liquid which can basically cool down the temperature of the reactor core by transferring the energy from the reactor core into the heat exchanger, and hence what kind of coolant selection needs to be taken up. And so there is a lot of research scope in uh, you know uh, making different kind of coolant for the different kind of reactors, because we will see like there are the different kind of nuclear reactors. We'll see the types, what are their types also. So the coolant also that comes in the field of chemical engineering or the chemistry. What kind of fuel should be designed, how the fuel should be designed, that is a main part of the physics. And so that it can, the fission reactions can be taken place very smoothly with a more efficiency. And then the design of the pressure vessel also makes a very important role uh, for the life of the nuclear reactor, as well as the integrity of the entire process, for which the mechanical engineers required, and the material engineering is also required, because it requires what kind of material should be selected. Okay, and mm, then there is a control shielding also. You can see in between the reactor and the pressure vessel, there is a control shielding where the gas basically used to fill, so that the temperature uh, of the outside boundary should not be very much. And because the gas is a very good insulator, the temperature insulator, so it is filled with the gas. So yeah, and like the reactor core, it consists of the fuel elements, the control rods, the coolant and moderator. And cores generally have the shapes of light circular cylinders with a diameter that ranges from 0.5 meters to 15 meters. And these geometry plays an important role for the efficiency of the reactor. So a lot of research scope is there for to optimize the uh, basically length and geometry of this course, and for which various mathematical models and a lot of analysis, physics analysis is taking place. Coming to the reflector, as I have already discussed, so whatever the neutrons that were trying to escape from the reactor core boundary, and so basically reflector is imposed into the pressure vessel, it in the form of coating, so that whenever any neutron try to escape from this boundary, it can reflect back. Okay, so that the we can the control the population of the neutrons, because the neutrons are the precious, and these are the ultimate source of energy. So it is placed around the core to reflect back some of the neutrons that leak from the core surface. Now coming to the fuel, that is the very, very important, component and aspect of the nuclear reactor. And generally uranium-235 is taken as a basic fuel. And the fuel is formed in the terms of pellets. So there are the small pellets of uranium oxide, and those pellets are basically arranged in a tube. So if you are able to see, there are four bundles, and in one bundle there are many tubes. So consider only one tube, and in this one tube there are many uranium pellets depending on the size of the tubes. Size means what is the length and what is the diameter of this tube. So based on which the uranium oxide structure also driven, and this fuel, the geometry of the fuel is varying depending on the type of the nuclear reactor, and the type of the nuclear reactor and the size of the nuclear reactor. For example, size in the sense in terms of how many megawatt of energy it can produce. For example, if we are having the 220 megawatt of energy, definitely the Calandria size will be less. The less tube bundles will be required, fuel bundles will be required, the shape will be little, shape and size will be little less. Okay, and if we are comparing with that of 500 megawatt of nuclear reactor or 700 or 1000 megawatt of reactor. Now the control rods. So we have seen the roles and responsibilities of the control rods, and this is basically to control the neutron population. And so that because we have to ultimately control the power if there is 220 megawatt of nuclear reactor which is producing, which has a capacity factor of 220 megawatt, then definitely I should ensure that power should not be rising up. Otherwise, because all the instrumentation and mechanical components are designed, considering the all the process parameters within that range that will be suitable for 220 megawatt of energy. So if you are able to see this pictorial view, there are the control rods, which are basically hangs from the mechanical clutch where the control rods can be driven, and which is basically operated by the electronic relays. So there is a lot of scope of the research in the field of electronics, that how electronic relays can be designed. And because that electronic relays are, controlling the immersion level of the control rods. So you are able to see in this figure that some of the control rods are immersing, uh, uh, more more percentage of control rods are immersed into this reactor core, and some is immersed very partially. So it depends like where you want to control the neutron population. And there are the detectors, or there are the physics calculations which basically converted into the software program, which basically gives the neutron population of each and every zone. So whatever the zone I want to control the neutron population, accordingly the control rod are derived basically, and which is also being controlled automatically with the help of the program. And generally, this control rod, these are made up of cadmium or boron, as we have already discussed. So if you see, so functions also we have discussed. Ultimately, it has to slow down the rate of the reaction to a controllable limit, or otherwise the chain reaction blows up like a nuclear bomb. And raising and lowering the control rods allow operators to control the rate of a nuclear reaction. That is very important. Right. Now, coming to the moderator, although we have touched on the moderator and we have looked the function of the moderator is basically to slow down the neutrons, because in every nuclear reaction that basically generates 2 to 3 neutrons, those are the high neutrons, high speed neutrons, and which contains a very high energy levels. And we need to thermalize, or we need to lower down the energy levels of these neutrons. Otherwise, it will not be able to strike the uranium nucleus, and the fission reaction will not be able to sustain. So ultimately, the role of the moderator is uh, to maximize the probability of the neutron to hit the fuel rods. So you can see this pictorial view where the low temperature water or the coolant is going into the reactor core inside the pipe, which is passing through the reactor core, and it is exchanging the heat, because a lot of fission reaction is taking place inside this nuclear core, and that heat is basically that cold water is now going out, and uh, so so this is the way, like it is this going out in the form of high temperature. Now this has become more high temperature water, and which goes to the steam generator that transforms the water into the steam, which contains the two logical compartments. So you are able to see this. So the moderator, which is in a yellow, color, and it is the entire reactor core is filled with the moderator. So in the form of stripes, or if it is a pressure vessel, you have to just flood it like this, so that the fast neutrons will be able to thermalize, and it can again hit to the uranium nucleus to maximize the probability of hitting. So there are a lot of research scope in the moderator, because the efficiency of the moderator plays a very important role, and the main moderator that are being used in the different kind of nuclear reactor are normal water, uh, heavy water, graphite, beryllium. But you have to be wisely select this moderator, because you might have heard the accident uh, of the Chernobyl, where the graphite based moderator was used, and this was the main reason of technological. The main reason was administrative reason, but technological reason was related to the graphite. So you have to really widely choose the moderator depending on the type of the reactor uh, that you are going to operate. And the coolant, so coolant is basically used to remove the intense heat that is produced into the reactor, and that heat can be transferred to the water in a separate vessel, which is basically converting the steam. This water is getting converted into the steam, and which is nothing but it is a steam generator, and that steam is used to run the turbine. So there are a lot of research in what kind of coolant that should be used in what kind of reactor, and the main coolant that are being used in the different kind of nuclear reactors are water, carbon dioxide, mercury, helium. But we have to again very wisely select, because if you see mercury is a very explosive, uh, and because then additional safety features needs to be incorporated. So all these there are a lot of research scope where you can perform the calculations and you can innovate the new coolant for the that can be best fit for the particular kind of reactor. Now coming to the containment, as we have seen, the containment was consisting mainly three components. One is the reactor vessel. Second is one is the reactor vessel, then is the pump, and the steam generator. So this containment is nothing but it is structure around the reactor. So because this reactor is under highly radioactive zone, and we have to always ensure that the radioactive component should not go out to the containment zone. Otherwise, it can be exposed to the public, to the normal public. So it is a structure around the reactor and the associated steam generator, which is designed to protect it from outside intrusion and to protect those outside from the effects of the radiation in case of any serious malfunction inside. So suppose, going back to the same slide, suppose if there is a leak in the steam generator, for example, and so what will happen? The radioactive components will be out of the box and it can go to the containment zone. And if suppose there is little leak into the confinement shell, it can go out of this confinement shell. And hence, there will be the breach of one barrier of the safety. And hence, it is very much essential to design the containment with by considering all these issues, all these safety measures, and using the international standards, we have to design the containment, which is the area of the civil engineering, and it is typically 1 meter thick concrete and it is made up of steel structures inside the concrete. There are the steel liners basically. So now let me try to explore more about the containment design. First of all, why inside the concrete we need to have the steel structure? Because the radiation, these are the alpha, beta particles and the gamma rays. And these are basically coming out from if they will be trying to coming out from the containment, they can hit to the steel-like structure and which has a property to reflect back. And moreover, inside the containment, we have to maintain the negative pressure. Why negative pressure? What is the benefit of maintaining the negative pressure inside the containment? Is that we can ensure that the radiation or everything can come from outside to inside if there is a leak inside the containment, but it should not from inside there should not, and anything should not go outside to ensure like the radioactivity is confined within the structure. Now if you look about the nuclear power plants in India, so India is planning a huge increase in the nuclear power plant, and it's it is one of its key policy initiatives with the plans to build 48 new reactors and boost the output to 63,000 megawatt by 2032, which is almost the 14-fold energy on the current levels. So the country's existing 20 nuclear reactors generate about 4,700 megawatts. I request you all of you to mute themselves because I think I'm getting the noise. So the people who are interested, at least they can listen. Yeah. So you can see like this is the map of the India, and you can see everywhere in all the parts of the country, we do have either nuclear power plants already in operating condition or under construction, or some of the nuclear power plants are proposed. So, for example, if you see the Rajasthan, you can see like there are several nuclear reactors, 1 into 100 megawatt. It means there is one unit of 100 megawatt and 1 unit of 200 megawatt of energy. The 4 nuclear reactors of 200 megawatt, each of 200 megawatt, 220 megawatt, and the 2 reactors each of 700 megawatt of energy. So if you see, the red bullet shows like these are under operating. So there are 6 reactors that are under operation. One is one reactor of 100 megawatt, one of 200 megawatt, and 4 reactors, each of 220 megawatt of reactor. And in the yellow bullet shows the nuclear reactors which are under construction. So the 2 reactors, each of 700 megawatt, is under construction. Similarly, you can see the statistics of operating and under construction and proposed nuclear power plants through this map. And you can see like there are many of the reactors are now in proposed condition. For example, Chutka, that is in Madhya Pradesh, in Bhimpur, that is in the border of Madhya Pradesh, Kovada, where we are planning. Already the government has sanctioned, has given his approval, and now the construction is under planning phase. Now, let us understand the classification of the nuclear reactor. So, because there are several types of nuclear reactors. For example, the Russia, it is making light water reactors. The Germany, it is making the light water, but it is a boiling water reactor. It is where boiling is allowed. Where Russia is making light water, but it is pressurized water reactor, where boiling is not allowed. For example, India is pressurized heavy water reactors. So different type of nuclear reactors are basically under are there and depending on the expertise of the scientists, the country is utilizing their expertise to construct the particular type of reactor. So we can classify those nuclear reactors based on various parameters. So these are the various parameters. For example, on the basis of neutron energy, I can classify the reactors because we have seen that neutron energy, we had thermalized the neutron energy for which we were using the moderator. But there are some nuclear reactors which basically make the use of the fast neutrons. For example, the fast breeder reactor, which is under construction in the Chennai. Okay, so that is the world's first reactor, fast breeder reactor, which is under construction in India, and which makes the use of the fast neutrons. It doesn't need any thermalization. So the reactors which work on the fast neutrons are known as fast reactors, and which generate the fission reaction based on slow neutrons are known as the thermal reactors. So based on the fuel also we can classify the nuclear reactors. So the fuel can be natural fuel We can say the natural fuel, natural uranium is U238, where only 3% only U235 is there. So if we are using the natural fuel, then the pressurized heavy water reactor is there, and otherwise you may have to enrich the uranium. So the reactor which are using the enriched uranium are known as enriched uranium reactors, and which are using the natural fuel are known as natural fuel reactors. And based on the moderator, also you can categorize the nuclear reactor. So we know moderators are basically used to control to control neutrons, neutron velocity, and several moderators, different type of moderators are being used in the reactors. For example, water moderator, heavy water is used as a moderator, graphite is used as a moderator, beryllium is used as a moderator. So depending on the moderator, you can name that reactor accordingly. So then based on the coolant, so the coolant is, we know like the coolant is used to take out the heat energy from the reactor core, and that heat energy can be used to convert the water into the steam inside the steam generator. So based on this coolant, you can categorize a nuclear reactor. And there are the different kind of coolants known as water cooled reactor, gas cooled. Gas can use as a coolant. That reactor is known as gas cooled reactor. If liquid metal is used as a coolant, that can term as liquid metal cooled reactor. Organic liquid can be used as a coolant, so known as organic liquid cooled reactor. Now let us have a look on the pressurized water reactor. So if you see, although in the first slide we have seen the working mechanism, where we have not touched mechanism, we have not discussed what is the type of that particular reactor. But now we are trying to see some of the differences of the nuclear reactor. So this is a pressure water reactor. And you can see there is a containment shell. There is a reactor inside this. There is a reactor vessel, and from the reactor inside the reactor vessel, the reaction is taking place. I think I'm getting my voice, the echo of my voice. So I request you all of you to mute themselves.
So we have muted all the participants. You can go on with your lecture. Thank you.
Okay, I think your voice is also getting echo. Should I?
No, I'm just no. So I've just switched it on to tell you that I'm unmuting myself.
Okay. Yeah. So in the containment, there is a reactor. So you can see the reactor vessel is there, where all the neutron reaction is taking place, the fission reaction is taking place, and inside this the steam generator. But here you are able to see one more component known as the pressurizer. And why this pressurizer is required? Because if it is for example, 540 megawatt of reactor, which is large in size, and hence it is very difficult for this reactor vessel to maintain the pressure of this liquid up to the point that it reaches to the steam generator, and hence to maintain this into the liquid state, we have to put one additional pressurizer in between. so that we can ensure that it will be this liquid, the water will be passed on in the liquid state into the steam generator, and that can transform this water in the steam generator into the steam. And that can be, again go to drive the turbine, and it can couple to the generator, and which can connect it to the grid, and that can be reached to the consumers. And rest of the working is entirely same, so we don't need to discuss. Now coming to the boiling water reactor, if you are able to see this figure, one interesting fact that can be brought out is that here there is no steam generator. So who is responsible to rotate the turbine? Yes, the steam is only responsible, but now instead of having a different steam generator, the reactor, in the reactor vessel itself, the steam is getting generated. So here we are allowing boiling. So it is known as boiling water reactor inside this. So we are not this. So this in this type of reactor, the reactor core is not maintained under the pressure. So here the boiling is allowed, and this is so this similar fashion, like it go to the to rotate the turbine, and then it can couple to the generator. So you can see like rest of the things are same, but let us try to look from this difference, what are the technological challenges and what are the advantages, why such type of reactor exists, and what are the technological challenges or technological differences between these two type of reactors. So first of all, let us talk about the advantages of the boiling water reactor, where we don't use the steam generator. So we can see because I have removed the steam generator component, so where a lot of mechanical valves, pumps, pipes, and all those additional mechanical components were required. So definitely I can take the credit of now not using these additional mechanical components, because now instead of the separate steam generator, I'm allowing the water to get converted into the steam inside the reactor core itself. And hence the reduction, if you say, it's a substantial reduction. Almost 50% fewer valves are required, 35% fewer pumps are required, 80% less pipes are required, 45% less seismic volume, building volume is required, 70% less cables are required. But we have to see the disadvantages also. And if you include the disadvantage, if you see the disadvantages, there is a possibility of the radioactive contamination in the turbine mechanism. You can see, you can go back here and see. If there is a radioactivity inside, because there is a radioactivity inside this pipe, because ultimately the radioactive components are in the reactor vessel, and which is now directly coupled to the turbine. Earlier it was loosely coupled because it was connected through the steam generator, but now it is directly coupled, it is tightly coupled. Then what is happening basically, it may be possible that this radioactive can go into the turbine, and hence now your radioactive component may have crossed the safety boundary of containment structure, and which is very dangerous. So extra safety measures you need to take. So there is a possibility of radioactive contamination in the turbine mechanism. So definitely we have to take additional safety precautions, and which can be turn out more costly because you may have to hire the safety experts, the safety standards, and the safety systems, additional safety systems you may have to use, and all those definitely will be more turned up to more cost. Wasting of your steam in this boiling water reactor, there is a huge wasting of steam, and that results into the lower thermal efficiency. And if you see the only 3% or 5% by mass can be converted into the steam per pass. So these are the disadvantages. Now this is the control room, and because we have touched the research scope in physics, in electronics, somehow in the chemical, civil engineering, mechanical engineering, material engineering, but like computer engineering and electronics, more electronics engineering and electrical engineering also, we have to see in what way these technologies are being used and what are the research scope in these technologies for this, in the field of nuclear energy. So this is a typical control room structure of a nuclear power plant, and if you see the associated components in the control room, there are electronic components that includes the various computers, different kind of computers, different kind of displays. You are able to see the desktop displays, the wall unit displays of different size. Biscuit PCs are there, which are having very, very small displays. There are various hand switches, electronic hand switches. There are various analog meters, digital meters. Analog meters is basically to know the analog process parameters, know the value of analog process parameters. Digital parameters are generally like opening and closing or of some equipment. For example, valves are open, valves are closed, pump is on or off. So all these more additionally, you are able to see on the wall there are the red color displays, small displays, which are nothing but are the alarm windows. And whenever any process parameter deviates from the normal design limit, it generates the alarms, and it also generates the voice so that the operators can pay attention to it. And there are, wall clock, digital clock, and every electronic component is synchronized by the digital clock. It means every computer should not have their individual clock. So that whatever the event is occurring, that has to be displayed with a consistent time information. And now you can see the technology that involves and basically these computer-based systems are used to monitor the healthiness of the plant and to take some control actions or safety actions. If you see the monitor, what could be the various features or what could be the various parameters which can be used to monitor the healthiness of the plant. That could be the pressure inside the pressure vessel, the temperature inside the pressure vessel, steam generator level. Steam generator level, why it is important? Because if you are having less water into the steam generator, how it can be converted into the sufficient steam, and it will be, and you will not be able to cool down your reactor, because ultimately the heat of the nuclear reactor has to be exchanged with the water that is inside the steam generator. And if steam generator is having very less water or no water, it will not be able to exchange the heat. And ultimately your fuel will start failing, and your mechanical components, even the pressure vessel and all those will start compromising, because the fuel temperature, it's almost 1000 degrees centigrade. And so ultimately, so monitoring is, there are many areas, other parameters, and for that, different systems are there. And each operator will be the expert of that particular system. For example, if there is a shutdown system of the nuclear reactor, which is responsible to shut down the reactor in case of some emergency, there will be the operator which has the knowledge of the shutdown system. If there is, similarly several kind of systems, like for example, the control systems, I'm monitoring the control system, then definitely I should have a good expertise on the control system so that I can understand each and every parameter, and in case of any parameter is approaching to the non-desired value, some actions can be taken up. Although all the actions are in auto, but still the manual intervention is required in case of some failures, or in case of situations which have not been postulated while designing these computer-based systems. And you can see, so if I'm saying that in the computer, you have to, in the computer, you have to basically understand each and how the software we can design. So you have to be a software engineer, where you can follow the entire software development life cycle. That starts from the software requirements to software design to software implementation, software testing to software deployment. And you have to really, different experts, because the software designers are the different experts. Software analysts are different experts. Software implementers are different experts. Software testers are different experts. So you have to have an expertise of all those fields. And so there is a lot of scope in research in how to design the good practice, how to design the good software using the best practices, how even, the operating system, basically we make our own operating system, because we cannot rely on outside operating system because of the safety concern, because we don't know the design of the operating system, of the existing operating system. And if I don't know the design, I cannot know how the inputs that I will be providing it will be handled by that of particular software. So definitely, so there are the different divisions. For example, the computer division that takes care of the design and development of the operating system, design and development of the compilers, because whatever the software design that needs to be implemented in the form of code, and code you have to compile with the help of the compilers, and compilers also you cannot trust on the ready-made compilers. So you have to design your own compilers, and Then, so there is a huge scope of compiler design, how it should be designed. There is a huge research scope in operating system. What should be the features that should be built into the operating system? There is a huge scope in the network, computer networks. Why? Because all these computers are connected with a network, and how to manage. So the network engineer and the computer net and the person who is having a good knowledge of computer networks are required basically for uh, establish the networks properly, and so that it should even the virus and all those stuff should not enter. For that you have to adopt the good practices. The security, you have to do a lot of research in the security, how security mechanisms can be cultivated. And then if you are able to see, there are the various large displays on the wall display unit, where the things are displayed in a very big image. So definitely there the image processing plays a very important role. So you should understand the image processing principles, how you can work on the images, how you can work on the analysis of the images, and what decision you can take out from analysis. All those things you have to really work. And you have to understand the instrumentation point of view, because every component is arranged. It is not a haphazard arrangement of electronic component into the control room. There are the various standards that basically that has been uh, developed prepared by the international agencies looking at their experiences of several years. So taking all these experiences, and you have to just adopt those practices. And then there is a huge research scope in electronics area, because you are able to see there are the various analog meters, digital meters, how you can design those analog meters, digital meters. There are the various hand switches, which can work on two states and three states. You have to come up with a proper design. So those are the aspects of the electronic engineers, plus the sensors, because which are installed in the field. For example, the pressure sensors, level sensors, temperature sensors, which are basically reading these parameters. So the sense and how the fusion technology of the sensors, the fusion mechanism of those sensors, all those there is a huge research scope in all those stuff. And then how the information can be scattered, that can be passed on the different modes, different processing modes, and how it can be sent to the analog input card, digital input card, which basically can process these parameters and communicate to the display unit to convert those process parameters into the engineering units. So all these are the research scope basically, which are the very important to address. And definitely in the field of electrical engineering, it is a lot of scope how to design the electrical system for the different type of computer based systems. For example, if it is related to the safety, even if 1 millisecond interruption is not allowed. So how to design uninterrupted systems? What are the batteries? What should be the design of the batteries? What should be the combination of the batteries? The AC power supply to these components, these devices, or DC power supply. What should be the voltage rating? What should be the current rating? So these are the important aspects like that really has a lot of research scope. And so this is the closed loop, close pictorial view of this control room, where you can see there are the alarm windows on the top side, which can be basically blinked in case of any unwanted signal comes. And these are the biscuit PCs, small PCs. So the systems which are not very important, but information is definitely required at some, not very frequently, but probably daily. It is essential to monitor such information. Those kind of stuff can be put in the biscuit PCs. And the displays, these are the big displays, and industrial PCs basically are being used because it has the robustness is very much, and it can sustain on the varying operating conditions, high temperature, low temperature, continuous, 24 hours operating like so. Now let us look some of the nuclear power plants which are in commercial mode in the different parts of the world. And what is the reactor type? So if you see the pressurized water reactor, the main countries that are in this type of reactor is USA, France, Japan, Russia, China, South Korea. And 299 reactors are under operation that gives 283 gigawatt of energy. And the fuel that they are using is enriched uranium oxide fuel. The coolant that they are using as water, the moderator, they are as water. Similarly, the boiling water reactor, the main countries that are doing business for this particular kind of reactor are USA, Japan, and Sweden. The rest of the statistics are given, and it is also using enriched uranium oxide. So these are the total statistics. So the type of the reactor, whole type of the reactor includes pressurized heavy water reactor, gas cooled reactor, light water graphite reactor, fast neutron reactor, like this. So that's all I wanted to share. And if you do have any questions, I'll be happy to answer those questions.
Thank you very much, sir, for your presentation. It was a very detailed and elaborative talk on the reactors and the scope of nuclear energy and the research methodology and objectives associated with nuclear energy. Very esteemed to have your presence in the FDP, and we are very privileged to have you one of our speakers in the field of nuclear energy, and association with BARC is kindly invitable for us. So I would request the dignitaries and all the participants if they have any question for sir, because it's a limited opportunity we have with sir. So if you have any questions, you can go on with your question. Are there any queries or participants for sir? Sir is waiting or entertaining the questions if you have. So it's because sir has explained each and every step very clearly. So if you have any doubt, you can question sir. Queries.
Good afternoon, sir.
Yeah, good afternoon.
This is Dr. Ramalingam, Professor, Kumaraguru College of Technology, Coimbatore speaking, sir.
Okay.
It was very nice, interesting, quite informative. We enjoyed your stuff, sir. And for your, and I was in BARC for 3 months from 10 years back for some 3 months training, sir. It was a very nice training, and I was a bit late. I don't know your address and other details, but is there any chance for the life science faculty to have a R&D project from the BARC or other agencies, sir?
I mean, in what context you are asking with respect to? I mean, you want to pursue some professional training, or in
Yes.
which context you want to ask?
Okay.
You are interested in pursuing some training or what, like? Or
Training and some R&D project from the bar. Like
R&D projects, see, regarding the professional training or everything, you will be able to get from the website.
okay,
And
sir.
regarding the R&D projects,
Yes.
basically we do have the BRNS scheme, that is Board of
Yes.
Research in Nuclear Sciences,
Yes, sir.
and who basically invites the academic institutes
Yes.
to make a project proposal that should have some research credentials and
Okay, sir.
innovation.
Yes, sir.
And innovation in the sense, like whatever the technology you are going to use, I mean, there is some kind of innovation, and the end product should be useful to the to any utility that comes under Department of Atomic Energy.
Okay, sir.
And so you can, because as I said, it is a multidisciplinary domain, nuclear energy. So irrespective of any domain you are, you can make a proposal, and you can, uh, put the proposal, apply that proposal online, and everything is online, the detailed description, how to apply, and what is the procedure, what
Okay.
are the inputs required, that are given in the BRNS website. So you can go
Oh,
through that, and we are always welcome. Um, we always welcome the participation from the academic institutions in for any contribution in the field of research and development in
okay.
that area. So you can go for it, and every information you will be able to get there.
Thank you. Thank you very much, sir.
Any more queries for sir? Or you want to have any conversation of any kind of R&D sort or any project with sir, you can go ahead, all the participants and the respected dignitaries. If
Hello,
anyone
sir.
wants any type of conversation,
Yeah.
yeah.
Yes, sir. My name is Jishnu. Sir, I'm a research scholar from Kerala.
Mhm.
Sir, I have a doubt, sir. Sir, compared
Okay.
to other renewable energy sources, we know that nuclear energy is having a lot of advantages, like even the productivity, even the quantity of electricity produced and are all very high. Sir, and you spoke about all the research opportunities regarding the power production and different stages of power production. Sir, my question is, are there any good researchers in India or around the world going in how to properly manage the nuclear waste?
Yeah, nuclear waste, there is a lot of research is going on, and nuclear waste is now basically managed by the utility, which is into this business. And generally, there are the three kind of nuclear waste in this nuclear power plant. That are the solid waste and liquid waste and gaseous waste. So generally, the solid waste basically is buried under the ground inside the nuclear facility only, and the liquid waste basically we do have to convert into the solid. We have to separate it out into the solid parts and to the liquid part, and the liquid part can have a different treatment, and solid part can be treated like this, and which can be converted into the gaseous form, and that can be filtered away from the HEPA filters, and so that all the radioactive components should not go into the public. And all these current practices are being followed throughout the worldwide, and more and more research keeps on going up in what way, like we can improve the things, in what way we can innovate the things. But we do have a very good waste management plan that is happening. And every if you are into the nuclear reactor business or nuclear energy business, you cannot take your own decisions. You have to follow the international practices, because ultimately the regulators are the international regulators, although you do have the country regulators, but International Atomic Energy Agency is an international regulator who is looking on the nuclear energy programs of the different country, and he also have it also monitors whether the current practices are being followed as has been discussed or as has been documented by the international forum. So the periodic meetings and all those keeps on conducting from the different countries. We meet at the common platform twice or thrice in a year to discuss more advanced technology or something can be bring out some in terms of improvement. So it's a continuous improvement and continuous process that keeps on going on.
Thank you, sir. Sir, I just wanted to know that whether there is any scope in utilizing or extracting any kind of energy out of the nuclear waste.
Nuclear waste, yes, a lot of energy, because ultimately nuclear waste is what, like plutonium, when uranium gets converted into the plutonium, and plutonium can be used for the nuclear bomb and other radioactive isotopes. You can generate more many radioactive isotopes. So definitely you can keep on recycling, and you must have heard about this nuclear three-stage program, in which the waste from the first stage gets utilized into the second stage for nuclear energy production, and the waste from the second stage can be recycled, can be taken up for the third stage, and which can be recycled. So definitely there are a lot of programs where we can reuse the waste, existing waste.
Okay, sir. Thank you, sir. Thanks for the informative reply, sir. Thank you, sir.
Excuse me, sir.
Thank you very much, sir.
Excuse me, sir.
Go on with your.
Sir, this one thing.
Yeah.
Normally, since I am working on removal of dyes from the wastewater, textile wastewater using annular centrifugal extractor. Hello, sir.
Yeah. Please tell me.
I'm using annular centrifugal extractor to remove the dyes from the wastewater. Such that annular centrifugal extractor is used in nuclear this bark or in Kalpakam. And can we make use of metal like uranium, similar metal that can be used as a model using centrifugal extractor that can resemble the removal of the unused thorium or uranium from the wastewater, sir?
I could not understand your query.
Sir,
Yeah.
I am using annular centrifugal extractor to remove the dyes from the wastewater, sir.
To remove the
Dyes, synthetic dyes from the textile industry wastewater.
okay.
This annular centrifugal extractor is used in atomic power stations for removal of the unutilized thorium or uranium from the wastewater, the liquid
Means
wastewater.
you are removing some some waste from the water.
No, sir, we are in dyes from the wastewater, sir.
Okay.
But I want to collaborate with nuclear BRNS to remove the any other similar metals, so that we are effective in removal of the dyes from the wastewater using organic solvents, sir. And
Yeah, so definitely, as I said,
yes, sir.
whatever you do have, you want to make your contribution, definitely you can make your contribution, and for that you have to apply to the BRNS. You can submit a project proposal in the BRNS that will be reviewed. That will be that will be taken up forward with the existing scientists who can review your project proposals, and they can think like if it is having some industrial value, and accordingly like the things can be taken forward. So in this way we can you are always welcome to do that. So and everything, like you will be assigned a project collaborator from here, where
yes,
you
sir.
can basically who can guide you, and who can basically try to plug your research work into our utility.
Yes, sir.
Yeah.
Thank you, sir.
Any more queries if you want to ask sir, because sir is available for a limited time and his presence is distinct with us. Any more queries or conversation any one of the participants would like to can have with sir? Sir, look like there are no more queries on the participants end, sir. So very warm thank you to you, sir, for the informative and knowledgeable talk you gave on the nuclear reactor and the future scopes it has in its field, sir. Very, sir, privileged to have you to associated with the Lucknow University FDP program, sir.
Okay, thank you.
It's
Thanks.
our pleasure. Thank you. It's our pleasure to have. Our next talk is scheduled for Engineer Yogesh Singh, who is a SRS scientist from National Institute of Solar Energy and a renewable energy consultant and expert in the field of renewable energy. He will shortly join us. He is trying to connect with us. We have got a mail from him. He is trying to connect with us. So he will join us shortly, and he will tell you about the various simulation and techniques used in photovoltaics and how to use them. So kindly be patient. We will take a break for about 5 minutes and then come back with the session so that we can join with Yogesh sir and enjoy his talk on simulation techniques in the photovoltaic technologies so that you can the industry person and the researchers can accommodate his ideas in their work and benefit from that. Thank you very much, sir. We'll meet in 5 minutes time.